Welcome to the Idea Ingemination Journey. This is episode 4 for 2025. Welcome to the first in a series of videos on Project X1, the yet to be properly named project that's kicking off this channel. So Project X1 has a series of goals. I'm wanting to learn embedded Rust. I'm very keen to build up a repertoire of RISC-V platforms, and I want to document the process on YouTube. What's this Project X1 going to look like when we finish? It's going to be a USB connected device that can be controlled from the PC via USB communication device class. It'll be a REPL style control interface, so we can enter commands and see a response from the system. Hardware wise, the peripherals that will include are 2 LEDs. We should be able to turn them on and off independently. A rotary encoder that will take our input and determine whether it's fast or slow, counterclockwise, clockwise. I'd like to have a small SPI connected LCD, and finally 2 UART terminals that offer that same REPL but potentially allow 2 of the devices to talk to each other over the UART and concurrently talk over USB CDC to the PC. So what's the target hardware for this Project X1? I'm intending to use a CH32V307 evaluation board. This is something I picked up off of AliExpress, and I think it constitutes a good target for doing this project. This is what the hardware looks like. You can see that we've got the main processor right here. If we zoom in, it's the CH32V307. And you can see that all the pins around this 100 LQFP part are bored out to the headers, and the hardware that's already on the board tends to be linked by these headers rather than directly to the pins. So this LED one is jumped across to PB4 because the LED up here doesn't hog that pin, and we can connect this LED to any other hardware. So let's take a look at this RISC-V MCU. It's got a RISC-V core, including floating point support. We've got USB, which we require for connectivity to the PC. Got GPIOs for the LED control. We've got our SPI for the LCD. And we have UARTs, many UARTs, so that'll be useful connecting the 2 boards to each other and have communication concurrent with the USB comms. So where am I at so far? Well, I was able to do a Blinky, a proof of life, taking a Rust binary and programming it onto the board. I've got a quick video of that here. So as you can see, it's blinking the LED. Where did I get that from? Well, we used a framework called Embassy, and it has an example project and it blinks the LED. And I was able to get that to compile, and I was able to program it onto the board using JTAG. So RISC-V, Rust, that board, I've had a proof of concept. But there was a stumbling block. When I went to use a more advanced example, I got some pretty serious compiler errors. One of the particularly concerning compiler errors was one that said that the atomics might be broken in the RISC-V core or the implementation on that particular part. So I need to dig into that a lot deeper, but I don't have the experience with Rust embedded or with Embassy, or indeed with this particular part to really make rapid progress. So I think I'm going to change tack. So my new tack is to use ARM hardware. I have a number of development boards kicking around here, and one I particularly like is the black pill. So it's fairly simple. It's an STM32F411, and I went ahead and compiled the UART Hello World for that particular target, and it built. No compiler warnings, no errors. So I think we're on the threshold of being able to make progress. So this is the black pill board. It's a pretty standard sort of development board. We've got the USB we need. We've got an LED. We've got plenty of I/O. We've got the JTAG programming headers here, and I've put it in the breadboard, but I haven't soldered yet. And here's the particular microcontroller on that board. So, what have I done? Well, I compiled the Hello World example for the ARM target. It worked, and then I realized I hadn't recorded anything for the video yet. So I'm going to pause my development and get this together. So there's a lot to this project, but there's also some meta goals, and that's what makes this a idea and germination journey video. I haven't done a video with a voiceover before. I haven't taken multiple application screenshots and put them into a single video. I want to have some background music, and I want to release it in 4 hours. Well, I can assure you that the 4-hour release was very ambitious. At tea time today, I realized that 5 hours in, we hadn't even started recording. So anyway, ChatGPT and I developed this slide deck, and I'm going to go over that tooling for the remainder of this video. So here's what's going on as I'm doing this live voiceover. I'm navigating through the slide deck, and it's being served up by my Python script that I worked with ChatGPT on. So here's the behind the scenes view of the slide deck generation. You can see there we've got presentation.html. Where's that come from? So the slide deck was generated from a wiki. I'm using Redmine to manage my projects, and its markup language is called Textile. Here's the textile. That's just the raw text that's come from the server. Here are all the scripts involved in creating that slide deck. The whole process starts with the fetch wiki page Python script. So that pulls down the textile file that you can see here. That textile file is then converted into HTML by the script. And once each of those slides has been created, there's another script that adds navigation to those slides. I then take that style CSS file and the fonts and put that into the slides folder. In this case it was slide 6. And then I need to serve those pages, and that's achieved through this script here, serve slides. So here's the fetch wiki page script. You can see that the Redmine API key is taken from the environment, and then we enter the Redmine instance, the project, and the title of the wiki page we want to retrieve. And then it's saved to a file that matches the name of the wiki page title. Back in the work in progress folder, we can see the textile file that we've retrieved from the server. We now need to convert that to the full HTML. So the dedicated script is convert textile to HTML. Textile itself is first sanitized to remove any characters that are going to cause us issues when we convert to HTML. I'm not sure how correct all of that is, but ChatGPT generated that, so I just went with the flow. Following that is the convert textile to HTML function that takes our input and converts it to the output HTML. The content gets wrapped in an HTML header, and you can see that the content of the textile ends up in this body content field here. Let's take a look at the generate slides from HTML script. The script's pretty basic. Simply ask you where the large HTML file is and what folder you'd like to put the generated slides into. Its job is to take the large HTML file and split it into a series of standalone slides, each of which is delimited by an H2 element in the larger HTML file. The slide content is put into this div with a class of slide container. So it takes the slide title, puts it in an H1 element, and then the remainder of the content from the slide is put into this div here. Beyond that is all the background for each slide. One of the interesting things about doing this slide deck was to have the background be a random set of rectangles. So there's a full screen rectangle to give it the base background color of blue in this case, and then 10 random rectangles scattered around, and then styled using CSS. So let's take a look at the style CSS file that provides the appearance of the slides itself. So we set up the font, set up the background. We've got a slide container which defines a border around the content of the slide. And then the slide title's got a font size that's 12% of the screen height. Disregard what the comment says there. So what do the slides look like when we don't have that styling applied? So we'll start serving the slides. Okay, away we go. So here's the slide with the styling. That's it without. So as you can see, it's just the raw content. Let's reinstate the style sheet. There it is again. If we refresh the page, you can see that style sheet taking effect on the randomly generated rectangles that constitute the background. Okay, that's it for episode 4. It's been an interesting day. I look forward to the next one. Cheers.